Okay, we're going to use your graphing calculator today. However, you need to make sure you're in the degree mode. So hit mode, make sure degree is highlighted. In your y equals, put in the y equals the sine of x, and y2, put y equals sine of x minus 45. And graph those after you hit zoom trig. So go zoom trig and graph them. And then when you look at the second graph compared to the first, you realize that it's just shifted sideways 45 to the right. If it's shifted sideways, we call that a phase shift when we're dealing with a periodic function. Do the same thing for this one here. When you do that, you'll realize the second graph is shifted 90 degrees to the left. So we'd say we have a phase shift. So now go back to your go y equals sine of x, y equals sine of x, close your parenthesis, then a plus 2 after the parenthesis, and then graph that. Then you realize when you graph that, it's a vertical shift of 2 units up. Move the whole graph 2 units up. Do the same thing over here, y equals sine of x, close your parenthesis with a minus 1 after the parenthesis. You'll realize it's a vertical shift of 1 unit down. So going back to what we were looking at yesterday, the number in front is A, does a vertical stretch, it affects, or tells you your amplitude. B, once again, does a horizontal stretch, which affects your period. And then C, from what we just did, when you add or subtract something to X, that moves it sideways, which is a horizontal shift, which we call a phase shift with the periodic function. And then if it's something's added or subtracted after the parentheses, we call that a vertical shift. So now we're going to go ahead and find our amplitude, period, phase shift, and all that from this one up here and graph it. So your amplitude's absolute value, what's in front. We know our b's, what's in front of our angle, which is 4, so that's going to affect our period. So negative, whoa, just a second here. Yeah, sorry about that, negative hanging out. Not sure why, but plug in 4 for your b, so it's 360 over 4, so we get a period of 90. Now, what's afterwards out here is your vertical shift, so we're going to have to move it 2 units up. And then what's added or subtracted here is going to move it left, so we have a phase shift of 90 degrees left. If it was a minus, it would move it right. Now remember, your midline is a line, so it's going to be y equals, and it's always related to your phase shift, your d value, because your vertical shift is always what cuts your graph in half. So I would tear off a corner of your page, and then I put a marking on it of so many units apart. What doesn't have to be a set marking, it just has to be consistent. So then I would come along and I would do 4 evenly spaced tick marks. And so then I'll do my next one. Yeah, if I can get this lined up, there we go. And then I would do my last one, evenly spaced, with a piece of paper from the corner of your page. And then I would also do that an evenly spaced mark up and down. I'm not going to use 2 red marks. I'm going to just use the whole length of my paper. So I'll mark that up, and then I'll have to move it and mark that down below also. Then you have to remember, we'll get this moved out of here for now. You have to remember that sine, when we're dealing with sine starts at the origin. So you put a mark here, and then at your fourth, you're at the same. Halfway in between, you're there. Halfway in between the first two, your first tick mark is where you're at your top. So I got to put that there, marked here. Halfway in between the last two, that third tick mark, that's where you're at the bottom. So I'll put that mark there. And I didn't mark that right. I got to move this one down to the full length of my paper. So this mark over here should be down that full length of the paper, which I guess it pretty much is. Now, if I draw in a smooth curve between these, I'll end up getting my basic sine graph. And it's got to be a curve. Now I'll come along and start putting in my markings. Now you'll notice my amplitude was 3, so this is going to be 3. This would be negative 3. One full period was 90, so this right here is going to be 90. So therefore, this is going to be 45 degrees. Now, my graph actually continues on and repeats itself on each side here. So now I have 2 of my 4 things already done. I've dealt with my number in front, and I've dealt with this. I still have to deal with this part here. In this case, it's not really going to make a difference, because if I got to move my whole graph 90 units to the left and my period is 90, it's going to just move this next piece on top of it. So just a second here. It does repeat and continue on over here. So if I just move everything 90 units to the left, this piece here would then move over on top, and you won't really notice that we did anything. But technically, there's a phase shift to the left. So to do our vertical shift of 2 units up, we'll come along at this point. We'll have to go ahead and kind of figure out where 2 units is. 2 units is basically this distance here, so I'll bring up my piece of paper. And my 2 units is just slightly less than my original marks. So just a sec. I'm going to have to come along and then mark everything, moving it all 2 units up. So let's see, what color do we want to use? Oops, I want my pen back. Come on, just a second here. Okay, we'll try this again. We'll go up here. So I got to mark something 2 units up here. Then I got to move my piece of paper to the next key point. And then I'll have to mark that 2 units straight up from there. And then move it to my next key point of where I cross, and then mark it 2 units up from there. Go to my next key point, which is the bottom point. Mark it 2 units up from there. And then I'll go to my last point, and then I'll have to be able to draw in my final graph between these green points. So if I draw this in, and then you should indicate that that is your final graph, so I know exactly which one to look at. So that's, for the most part, how you would go about graphing these. Now, a more accurate graph would be what you see down below, but that's done with a computer. So for this one here, go ahead and find your amplitude, period, all that. Do your 4 tick marks on the horizontal. Do 2 tick marks, one above, one down below, and then we'll graph this. So as we look here, our amplitude's what's in front, so that's 4. Our b value is that 1/2, so it's going to be 2 pi over 1/2, and so we get 4 pi. You might be wondering, how do we know we use 2 pi instead of 360? That's because we have a pi right here. Our phase shift is in radians, so we know our period has to be in radians. If our phase shift was in degrees, we'd know our period was in degrees. We have a -3 on the outside, so we know we're going down 3. Our phase shift is that pi over 3, and then you need to tell me which direction. In this case, it's pi over 3 right. And then our midline is always related to that B value or D value. Here we're dealing with a cosine. So when we draw this out, we know at 0 cosine starts at the top. At the last one, it's going to be at the same height. The middle one, it's going to be at that same distance but down. And then between the first two, it crosses. Between the last two, it crosses. Then you're going to go ahead and draw in your basic graph. Then we'll mark these tick marks. This was up 4 because that's our amplitude. This is down 4. This is our full period, which is 4 pi, which this is 2 pi. So this would be pi right here. We now have to go ahead and move everything over 1/3 of a pi. So I need to look at my graph and figure out, well, where's 1/3 of a pi? Well, 1/3 of a pi would go from 0 to pi. I'd have to divide it into 3 equal parts. So this first one would be 1/3 of a pi, this distance. That distance is how far I have to move everything on my piece of paper. So I'm going to bring up my piece of paper and I'm going to mark that, and then I'll have to move everything in that direction. So I'm moving everything to the right 1/3 of a pi. So all these green dots have to be moved this blue piece. So I'll move this up here and I'll mark that. Move it to the next key mark and I'll mark that. Move it to the next key mark and I'll mark that. Next key mark. And my last key mark. I'll move that out of there. Now I'll go ahead and I'll draw in a nice smooth graph going through those points. Now I still have to go ahead and do my vertical shift. Well, to do my vertical shift, I need to go ahead and figure out what 3 is. I know this is 4, that's 0, so halfway in between is 2. Divide that, divide that. So I need to go ahead and move everything from here to here. That's how far I have to move everything up. So I'm going to take my piece of paper, have to turn it sideways, and I'll go ahead and mark that on my piece of paper, and I'll use that to mark everything of how far I have to move it. So I'll come along to this first key blue point, and then I'll mark that. Just a second here. Then move that piece of paper to the next point. Okay, just a second. Mark it, move it to the next key point on the blue, because that's the one that had our adjusted stuff on it. And then move it to the next key point. If I can grab the right thing here. And then we'll do our last key point. And then we'll go ahead and draw in our final graph going through all these black points. And these black points, when I draw that in, will have my correct amplitude, period, phase shift, and vertical shift. So now we're going to work backwards from a graph, and we're going to come up with our equations. Well, first of all, we need to find our max and our min. We can see here our max is 2, our min is -4. We find our A value by going max minus min divided by 2. We find our D value by going max plus min divided by 2. Now, what we have right here going from this point down to this point is really only half of your period. You really have to go another half to be able to get the whole thing. So if I figure out how far apart that red is from 195 to 465, I just have to double it to get my whole period. So my whole period, if I figure out how far apart those are, I have to double that. I get 4 or 540. So I can use peanut butter, your period, times your B value is equal to 360. Your B value times your period of 540 is equal to 360. So we solve that, and we get our B value to be 2/3. So we'll go y equals our A value of 3, cosine, open brackets, our B value, parentheses, x minus, oh, we'll figure out that in a bit. Cosine. Cosine always has its maximum right here, but our point from our maximum got moved over to here for our maximum. So when your maximum occurs, which in this case is 195, is your C value. And then we have to put in our D value, which is -1. And we'll do this last one. So could you go ahead and graph this? Yes, but we're going to look at our data and find our max and our min. We can see our min is right here of 6.5 highlighted. Our max is highlighted down here. So we'll go max minus min divided by 2 for our A, max plus min divided by 2 for our D. Your period, in the context of your problem here, we're dealing with daylight. We know it's going to repeat every day, so our period is going to be, in this case, measured in hours, 24 hours. So we'll go, our B value is 360 divided by 24, or in this case, 15. So we'll go y equals 17 cosine your B value of 15 x. Oh, we got to figure out our C value. Once again, C is when your max occurs. Normally it's occurring at 0. Our max is right here, which is at 1 p.m. So how many hours after midnight is 1 p.m.? Well, that's 13. So our C value is 13. And then we'll throw in our D value.